ladies and gentlemen. I just wanted to make one more video for you guys, just going through this homework problems with you, because I know this stuff's a little complex. So let's take a look at this, and feel free to watch at your own leisure. Okay, I'm going to explain all the problems in good depth, and of course, if you have any problems, feel free to ask in class as well. All right. Number one. But we have the fourth root of 32, x, y to the 8th, z to the 5th. I'm going to go ahead and do shortcuts to save a little bit of time, but for the fourth root, I have the fourth root of 2, 4, 8, 16. It's going to be the fourth root of 16 times the fourth root of 2. Because I'm breaking this up. Guys, use that chart that we made up. That's what it's there for. The fourth root of 16 is 2. Okay, and then this stays underneath here. Can 4 go into 1 because I only have x to the first? No, so the x stays underneath here. Can 4 go into 8? Yes, twice, so y squared. Can 4 go into 5? Yes, once, with 1 left over. Boom, done. Okay? Cool. Now, moving on, number 2. 2 to the 1/3 times 2 to the 3/4. I'm going to combine these in the middle together first. In order to do that, they need to have a common denominator. So 1/3 to 3/4, man, it's that tiny. I need to get 12 as my common denominator. So for 1/3, I'm going to turn this into 4/12. And for 3/4, I'll turn that into 9/12. 4/12 plus 9/12 is 13/12. Okay, I can multiply that in. So 13/24, done. Okay, 1/2 times 13 over 12 is just, you multiply the tops, 13 times 1, multiply the bottom, 12 times 2. There we go. That's all I need. Okay. Alright, this one. Technically what this looks like, let me write this bigger for you guys. X squared, y to the 4th, z divided by x to the 5th. Now, I have 2 x's on top, I have 5 on the bottom. I can get rid of these two. Get rid of 2 down here, and I have 3. So, alright, cool. Now, up top, the square root of y to the 4th. There's technically a 2 out here. How many times can 2 go into 4? Twice. So y squared. Can 2 go into 1? No. Alright, so that stays there. Can 2 go into 3 down low? Yes, once, but I have 1 left over. Here's the deal. We talked about this a million times in class, and I will use an example. You'll see why next year. Trust me. 1 over root 2. To rationalize, I have to multiply top and bottom by the square root of 2. That gives me root 2 over 2. You see I have a square root of x down here. I want to get rid of that square root of x. It's as easy as multiplying top and bottom by square root of x. I know it's a variable. Don't freak out. Same rules apply. Up top, I get y squared square root of xz. Down low, square root of x times square root of x is just x. Just like up top here, square root of 2 times square root of 2 is just 2. So now I have x times x squared. Okay, and that's supposed to be a z here, as terrible as that looks. Sorry about that. Okay, moving on. I love math. Oh my gosh, the best answer of all time. Hip hip hooray. You and me both. Okay, smile, because we all love math. Alright, number 5. This is the 1/2 power. Guys, you are not multiplying 100 by 1/2. This is an exponent. This is 100 raised to the 1/2 power, x raised to the 1/2 power. Please, I really want you to get this by this chapter. The 1/2 power stands for the square root. Square root of 100 is 10. Same rules apply here. I don't want to leave the square root of x down low, so multiplying top and bottom by square root of x. I get 10 root x over just x. Boom. Done. Okay? Alright. 16 looks brutal. Totally agree with you. I'm going to multiply everything inside the square root, or cubed root, together, and leave everything that's outside by itself. So only that x is by outside. Everything else is inside. 16 times 2 is 32. X to the 6th times x to the 3rd is x to the 9th. Y squared, y to the 5th is y to the 7th. Z is z squared. Cool. Now, for cubed root, the cubed root that goes into 32 is 8. Okay, so the cubed root of 8 times the cubed root of 4. I'm just doing side work over here to help myself out. Guys, what's the cubed root of 8? Just 2. So I can pull the 2 out. Now, I'm not forgetting about this x, but just bear with me, okay? How many times can 3 go into 9? 3 times, no remainder. So I'm pulling out an additional x to the third. But I already have an x out here. What's x to the third times x? X to the fourth. How many times can 3 go into 7? Twice. With the remainder. Okay, so I still have the 4 underneath here. And the y. How many times can 3 go into 2? None. So z squared stays underneath there. That's it. Okay, I'm going to rewrite this because that looks terrible with that space in there. Okay, I know this is a little confusing, but it's the same rules that are applying every time. You break down your number, use your chart. You see how many times this root power can go into all of these your exponents. Okay, how many times it goes in comes out here. Whatever's left over stays underneath the radicand. Okay, cool. Number 7. I got to break this down. It's the fifth root of 96. Fifth roots. Normally I'm dealing with 2s, like powers of 2. 2, 4, 8, 16, 32. So can 32 go into 96? Indeed it can. Alright. It's early in the morning. Bear with me. It goes in 3 times. So this is the fifth root of 32 times the fifth root of 3 minus 4 fifth root of 3. This is just 2. Alright, I have the same fifth root of 3. What's 2 minus 4? It's just negative 2. Okay, wonderful. Alright, done. You're not going to cancel these out. They stay the same. Just think of it like 2x minus 4x, you get negative 2x. Same rules apply. It just looks more difficult because you have newer things. Alright, I am multiplying everything underneath here. I am multiplying everything underneath here, and I'm going to subtract in the middle. Here we go. On the left-hand side, I'm doing numbers first. 3 times 3 is 9. X times x squared times x is x to the fourth. Y times y times y is y cubed. That's it. Okay, for as ugly and as complex as that looks, that's all that turns into. Minus square root. 6 times 54. Don't laugh, it's early in the morning. 324. X to the third times x to the third is x to the sixth. Y times y to the fourth is y to the fifth. Okay, now, here, I'm breaking this down. The square root of 9 is 3. Square root of x to the fourth is x squared. All again, I'm asking myself, how many times can 2 go into 4? Twice. No remainder. How many times can 2 go into 3? Once. Remainder 1. I'm done with that first part. Nothing else I can do. Over here, I'm going to, let's see, always check first if you can take the square root of what it is, because you might get lucky. And I did here. Okay, the square root of 324 is 18. So, 18. How many times can 2 go into 6? 3 times, no remainder. How many times can 2 go into 5? Twice, remainder 1. Alright, now comes the very good question. Alright, what can I do with this? I have x squared y, square root of y, x cubed y squared, square root of y. I totally agree with you guys. I got square root of y, square root of y. Hip hip hooray. But can you please notice that I have x squared y, x cubed y squared? They're different. Therefore, I am done. That's it. Just to relate this to something else that you guys know. If I asked you what 3xy minus 2xz is, the answer is just this. I can't do anything with it. They're different terms. Alright? So please don't forget that. Alright. Number 1, the area of an equilateral triangle is given by the area formula equals square root of 3 divided by 4s squared, which is a very good formula, by the way. Find the length of s of an equilateral triangle with an area of root 12 inches, square inches. I'm taking this and I'm plugging this in for a. So root 12 goes in for a, equals root 3 divided by 4 s squared. To get rid of a fraction on one side, you multiply both sides by the reciprocal. This cancels out. Really nice thing over here, because these are both under the square root, I can do this. What's square root of 12 divided by square root of 3? Square root of 4. What's square root of 4? I'm blowing up over here. 2. 4 times 2 is 8. I can break that down. Root 4 times root 2. 2 root 2 inches. Honestly, I mean, like, I love answers like that. It's great. If I'm talking about the side length of a triangle, very rarely do I want to have it in square roots. So I could just say, like, the square root of 8, which is s equals 2.82. I'm sorry, 2.83 if I'm rounding the nearest 100 inches. Either answer is acceptable. Please read directions, because I might ask you for one over the other on a test or quiz or whatever, but you get the idea. Very good problem. Expect to see something like this again. Okay. I know this stuff is complex. All right. But keep hanging in there. It's the same rules. Please, guys, make sure you're comfortable with this. X to the 1/2 power equals, because I'm just telling you, I've been doing a lot of SAT tutoring lately, and this has been coming up a lot. And if you know that x to the 1/2 just stands for square root of x, then it makes like a problem on the SAT. Like, granted, it's not going to be like every problem, but it makes like a problem that it would take you 2-3 minutes if you didn't know what was going on, like able to be solved in like 10 seconds. So I keep stressing this to you for a reason, okay, not just to be annoying. Please make sure you're comfortable with that, all right? And we should be good, but I will have some additional practice for you. Always feel free to ask questions. As always, good luck. We're all counting on you.